Okay, today I'll talk about some of the unmet challenges from the point of view of sensors and sources in semiconductor technologies. So if you look at semiconductor-based technologies, which are the basis of the intelligent technology, the age of intelligence, the technologies are almost transformative. If we see our lives 20 years ago and where we are now and how we use and interact with technology, it's profoundly different. They just almost seem magical. If you look at our cell phones versus the phones 20 years ago, or no phones before that, if you look at internet, laptops, the tablets, GPS system, it almost seems like now we can't live without them. They are so much part of our lives and have become almost like food and water. There have been some social studies done where people were asked to not use their cell phones or their PCs for a few days, and they almost feel the same level of deprivation as if they are starving. So they become such an important part of our lives that they are almost like food and water. And if you at some point lose the internet service, if you lose the wireless service, how deprived you feel. And I think it's almost becoming universal. And I personally feel that way, that if I'm not connected, there's something wrong with me. Something is happening, I'm deprived. So today we'll focus on, and we know all these technologies, today we'll focus on what are some of the needs that have not yet been met. Even though technologies are so magical, almost like anything can be produced in technology. But there are some things that haven't been produced, and some areas where technology has not made as much impact as it should for a variety of reasons. There could be cultural, political reasons. So I'll focus on semiconductor-driven technologies. Semiconductors by themselves are merging with other materials, merging with other intelligent systems, and then producing technologies to sense, to produce sources, detect, and so on. So we'll start by looking at how the technology has evolved and the march of technology. Where does the drive come from? And of course, the drive initially came from very basic things like survival. So whether building a fire, which is a technology, having a wheel, having a catapult. So survival, warfare, search for truth, looking into space, a lot of science-based technologies, entertainment, and of course more and more economy for jobs, for efficiency of systems. But specifically, if you look at where the drive is coming from, these are some of the main drivers. Telecommunication has been a very big driver of technology, and almost all the technology that we use today at some point came from Bell Labs. A lot of the technology was invented at Bell Labs in the 50s and 60s, driven by telecommunication. So the transistor, the laser, the semiconductor laser, a lot of those very critical pieces of technologies came from telecommunication. And of course, a lot of technology came from the needs from the military application. Then entertainment is now driving a lot of our technology. Right? So if you look at entertainment, video gaming, some of the highest end performance technologies are being driven by media and entertainment. Then healthcare is driving a lot of technology. As the shift in healthcare goes on, which I'll talk about in a moment, the need of technology in healthcare has expanded exponentially. And if you go into a hospital and you look at the technology that are present in the hospital, it seems like a very, very high-tech place. It seems like technology is the dominant. So the physicians are, of course, using technology, but technology is like state-of-the-art technology. Aerospace, transport, etc. But military, of course, is a big driver because it drives technology. Cost is often not an issue in military. And so other commercial drivers may lag behind, but military, because of cost not being as critical, drives high-end technology, then it eventually becomes commercial and goes into everyday life. So if you look at military, of course, the US spends the highest amount of dollars, in terms of dollars in military, about $700 billion. And the worldwide market for military is about $1.5 trillion. So about half of it is coming from the US driving. And military has been a major driver for the last, since the World War, Second World War, from the radar onwards, and of course, technology is becoming more and more sophisticated. So guidance systems, homing systems, lasers, microwave devices, with radars, receivers, night vision scopes, all of this has driven technology and produced great improvements in technology. The other driver, the big driver, is healthcare, because the healthcare market just in the US is $2 trillion. The military market worldwide is 1.5 trillion. So just in the US, so healthcare is a huge driver of technology. And as diseases have shifted, 30, 40 years ago, diseases were primarily communicable diseases, diseases that were not fully understood. And there are still diseases that are not understood. A lot of cancers are not fully understood. But more and more, the diseases have become lifestyle diseases, which the reason is more understood. But there, for whatever reasons, people are still not able to change their lifestyle. So if you look at, this is sort of in the US 2007, what are the reasons for people suffering and dying? More and more of the illnesses, almost 80%, are now becoming lifestyle disease. And technology is becoming very important, of course, to diagnose the diseases. So just in understanding and diagnosing diseases, that's a huge market, and it's driving a lot of technology. A lot of the semiconductor technology is going into healthcare systems to understand and then provide resources to the physicians.
So healthcare now takes more money than military?
Oh yeah, much more, yeah. So considerably more. You know, just in the US, as I mentioned, the healthcare is close to $2 trillion. And if you have the misfortune of going and spending a day in the ICU, you will see you know, how expensive it is. I was just reading that the cost of just about a little less than a month, if you're sick in the hospital itself, has started to reach $1 million. It's very, very expensive. You know, several $1,000s a day in the, if you're unlucky enough to actually be gripped by the ICU. So it's very expensive. Now, video gaming is a big driver of technology. Right? So it's entertainment, and it's mainly young people, children often are just wanting the fastest microprocessor, the faster processor, so they can compete worldwide. And of course, this is not a huge market, although it's growing very fast. It's nowhere compared to military or, but video gaming, for example, has exceeded movies as in terms of its market share. It's a big driver of technology. And people who participate in video gaming also are technologists often. And so they know how to drive technology and enjoy technology as well. So a lot of high performance technology is coming from the gaming industry. Now, we want to look, now there are some sites of the DoD, the Department of Defense sites. You can go to the internet and you can see some of the grand challenges in technology. So there are about 20, 21 grand challenges that are on various DoD sites, Department of Defense sites. And you can look at those and they describe what are the next level technology that we need. And I'm not going to talk about that because those come from needs that may not be needs related to good life alone. And those are very important needs. So if you go to DoD sites, you can see these 21 grand challenges, right? And where technology is needed. Right? And those are very important challenges. And of course, there's a lot of push towards meeting those challenges. And I will not talk about them, although some of what I'll talk about may overlap with those grand challenges. But I'll talk about what is needed from technology if you look at technology to provide us a sustainable good life. So if individually we want to have a good life, what additional things or less things should technology provide? So I can have a good life, you can have a good life. And that's becoming more and more important. So what is the drive for technology if the driving force is considered to be a sustainable good life? So sustainable good life has a lot of challenges because if the resources were unlimited, one can go one way. So if you are designing the best drone in the world and that's your motivation, there are some technologies you need. If that's not your motivation, there are other technologies. So if one looks at good life as a motivator, which means everybody should have a good life. So right now, even basics are not provided to more than 5 billion people in the world. So 80% of the world does not even have some of the basics. So the drive may be different. So drive coming from energy needs and constraints in our resources. Then globalization of the economy, where humans are becoming more and more like cogs. So you have these massive global factories and everybody wanting a good life. So there's challenge from that. The information age and robotics, where manufacturing is transferring, of course, not just overseas, not offshoring, but transferring to robotics. Right? So, and this will just accelerate more and more. Right, where almost anything that we do, robots can also do. So what kind of technology would be needed when that happens? Then, of course, healthcare issues and demographics, where the populations get old and the lifespan is increasing rapidly, and so there are challenges from there. So I'm going to look at some of the needs of technology from the point of view of good life. So individual wellness as a driver rather than the more sophisticated radar system as a driver. Right? So of course the radar system is very important and it drives technology, but what about individual wellness as a driver of technology? So if we look at, there are several elements that are needed, and some of them are very well understood and some of them are a little more esoteric at the moment, right? But they are profoundly important. So first, of course, we want knowledge and ability. We need to know things, right? So we need to have, if we perform in ignorance, of course, we waste a lot of resources and we flounder around. So knowledge and ability, which means understanding the path I'm taking, whether it's being a student or having a job or having a family. And here, of course, technology has provided a lot of resource. Right? Knowledge is now not scarce. It's available on the internet. And it's widely available. Physical safety, and that's an important issue. Being safe from injuries, from accidents, from diseases. Physical safety is an important wellness issue. How do we stay physically safe? And I'll talk about some of the safety issues where technology is there, but it's not inserted into systems for whatever reason. I'll talk briefly about the reason. For example, we still have 30,000, in this country, we still have about 35,000 fatalities from car accidents. Now there's no reason why that should happen. Because only 1 or 2% of those accidents, one can say there was really no reason. Right? Like the tornado came yesterday, maybe it didn't cause any accident, but there are some reasons why a car accident should occur, but 99% of the car accidents are actually preventable, and so technology is there to prevent them, but the technology is not inserted for whatever reason. So safety, that's an important personal issue. Everybody wants to be safe. Right? We don't want to be hurt. We don't want to be in an accident, lose a limb, get injured, or die. Then also environmental safety. I want to know, is the quality of water good? Environmental safety. Now this is a little more esoteric, where awareness of the culture I'm living in. That's becoming very, very important as we become a global community. Awareness of the culture I'm living in and the impact of the culture, and one may think, what does that have to do with technology? However, that's a very important part where technology can contribute, understanding the culture, because I may live in a culture that nurtures me. I may live in a culture that's toxic to me, and I want to understand. Is it nurturing? Is it toxic? And how can I then isolate myself? It's just like If you plant a seed in the soil, you want to know what the environment is. And culture is like the environment that nurtures a human being. Then self-awareness, knowing myself. That's a very important, and that's becoming more and more important as the economy becomes globalized, as robots do things that humans do. Knowing yourself, understanding your own purpose, and what can technology do to enhance my self-awareness. And now that again seems like something which is highly non-technical, because what does awareness have to do with technology? What does it have to do with gadgets? But gadgets can be very, very helpful in understanding myself. And then finally, also removing the gap between my knowledge and action. That's a very important gap. We often know what to do, but we can't do it. We may even have the resources to do it, we can't do it. That's a very common phenomena. In fact, it's very, very difficult to overcome this gap. Knowing something and then doing it. With all the resources around you, still not being able to do it. In fact, this is, I mentioned to you that more and more of illnesses, especially in the developed world, are lifestyle illnesses, which means they may be related to food we eat, how we sit, how we stand, how we interact with people, how we deal with stress. They're all becoming lifestyle illnesses where the knowledge is there what to do. But ability is not there to actually follow through. And technology can be very helpful in that arena where the gap between knowledge and action is reduced or removed. So we'll talk about some of these issues. Now this I mentioned to you, what can technology do? This is an old chart, and actually this is even more relevant now. The leading causes of, and this is called preventable, because these are lifestyle issues. Right? Preventable death worldwide, not just in this country, not just in the developed countries, but even in less developed countries. So this is worldwide. And interestingly, in 2008, the diseases are suffering from overconsumption. Those diseases and those deaths were larger than the diseases that arose from lack of resources. Right? So preventable diseases, which means closing the gap between how you are, how you behave, and what you know, is becoming extremely important. So this knowledge-action gap I mentioned becomes very, very important. Now, as far as wellness is concerned, so since I'm going to focus more on wellness and what technology can do in wellness, currently, of course, wellness is primarily in the hands of the medical system. Right? And so we don't think of wellness till we get sick. Then we go to the doctor, and the doctor says, do this, do this, do this. Right? So physical wellness, basically, one gets sick, and it's accepted that the body gets sick. It's accepted. Right? And so you go to the physician, and the physician diagnoses you, gives you either some drugs or some, because the physicians only have two things to do. They diagnose you, of course. They give you either a prescription or they perform surgery on you. Right? So that's the role of the physician. And of course, it's a very, very important role. But the physician gets involved primarily when you're already sick. Now, if you have, and increasingly the illnesses, especially in the developed world, are less and less physical originated and more emotional and mental originated. And this is not like you're going crazy. Mental illness is primarily relating from stress, inability to deal with stress. Right? And in fact, in this country, the highest number of prescription drugs are for antidepressants. Which means that mental illness, stress-related illness, has become more dominant than actual physical illnesses. And in fact, in U of M, in this university, if you look at the healthcare budget, which is enormous, it's an enormous budget, I think close to $230 million for University of Michigan. And out of that, a larger fraction is related to originating from mental health issues, okay? Manifesting itself as physical health also, but originating primarily from stress, inability to deal with stress. And there, one has, of course, therapy, which again, prescription drugs, antidepressants, various kind of other pharmaceuticals, or therapy from a psychologist. Then the knowledge action gap, which means being able to modify behavior, is also based on behavior therapy. So what can technology bring to this arena? And that's some of the things that briefly I'll talk about. So now switching to technologies, and primarily intelligent technologies based on semiconductors, and we all enjoy technologies, and we instantly absorb technology, and technology is so addictive. And even people who are really pushing technologies, once they start using it, it becomes very addictive, right? So if you have, I myself for the longest time didn't want to have a smartphone because I thought it's totally useless. And 6 months ago I bought one, and I'm addicted. It's like just I can't live without it, right? So if because it's so useful, at least I think so. And so technology is magical, it's addictive, it instantly changes your behavior. And that's the amazing thing too, that it instantly changes your behavior. If you have internet access, your behavior changes. If you have a car, your behavior changes. If you have technology resources, behavior changes. And it's very hard to change your behavior like technology changes. Right? So without technology, if you want to change your behavior, it's very difficult. But technology has this power that it changes your behavior. Unfortunately, often changes it in a direction that is not very good for us, right? But it changes your behavior. Right? So often technology does change behavior in a way that it's not good. For example, a lot of the ability to have a car and go everywhere in a car changes our behavior. We do things, but we are also sitting all the time, and we suffer from obesity, we suffer from other illnesses related to inactivity. But one thing is for sure, technology changes your behavior. And understanding that, and then evolving technologies in a way that change behavior in the way that is conducive to wellness, not to ill health, that's one of the things that is very important I'll talk about. Okay, so semiconductors, and I think all of you have some basic understanding of semiconductors. Basically, semiconductors are materials where you can change the electron density very easily, and through that you can control a lot of properties. So semiconductors can detect electric field very easily, very small electric fields. So you can have digital electronics, analog electronics. It can also interact with electromagnetic radiation. The semiconductors can interact very strongly with light, photons. So you have light emitters, LEDs, lasers. So you have cameras everywhere, and you have displays, you have detectors. Semiconductors can also convert energy from solar energy to electricity. You have light sources, energy sources. When semiconductors are merged with piezoelectric materials, you have force sensors. You can have devices that detect your motion, technologies like Kinect technologies, Wii technologies. So you can have all kinds of technologies coming out from semiconductors, primarily because of the way the electrons are in semiconductors, right? The band structure of semiconductors. And there are a lot of different semiconductors. Of course, silicon being the most dominant, but the other technologies also which are present. And the moment semiconductors merge with a new material, all kinds of new technologies come out. And that's the great thing about semiconductors. So if they merge with piezoelectrics, you have a whole range of technologies. They merge with ferroelectrics, you have another range of technologies. And there are many areas where semiconductors have not yet merged with other material systems, and that's a great opportunity for semiconductor technologies. Now, most of the technology we have, which is part of this intelligent technologies, whether it's the laptop I have here, or a smartphone, or any kind of tablet, they are based on basically 5 or 6 essential devices. Recently, New York Times had an article on Bell Labs and the technology that emerged from Bell Labs. It was like a history of Bell Labs, and a really interesting article. And it's interesting that since that period, very few new devices have come out. So if you look at the basic building blocks of technologies, they're basically a transistor, light emitter or light detector. Now, of course, touch screen, which are very simple technologies, piezoelectric devices, and liquid crystal displays and thin film technologies. And that's about it. So from these, you can build almost anything which is in existence today. So whether it's the latest smartphone from Apple or Samsung, or the latest thin television screen, or the tablet, it's basically built on these devices. Not very much new has come in semiconductors. Of course, the transistor in the 50s, the first semiconductor laser, early 60s, and since then, not a whole lot of new technologies have come, even though technology companies have, of course, become very, very dominant. Right? So as part of this article I was describing on Bell Labs, and this is not to simply glorify Bell Labs, although one has to acknowledge the contribution that came from there, the newer companies have not evolved many new technologies. They've used technologies, right? They've used technologies. But interestingly, this is about it. What is here is about it. This is the building. These are the building blocks of radar systems, guidance systems, all kind of detection systems, and so on. And of course, this has been driven by companies like Intel, which brought, driven by Moore's law and Mr. Moore here, where functionality doubles every 18 months and still going on, still valid after 50 years, which allowed, of course, these huge giant computers, which were only available to select companies, big governments, military applications, to every person, right? So everybody can now have access to knowledge, information, and technology. I had mentioned these devices. So basically, semiconductors still respond to traditional, like field effect transistor. That's the building block of all technologies. Pressure sensors, merging with piezoelectric materials. Essentially, all technologies like the airbag, some of the gaming technologies are based on pressure sensors, and some temperature sensors, but there's not a whole lot of other technology that has come up. And I'll talk about some of them. So that's where some of the needs are. Right? So going beyond these 5 building blocks, right? Going beyond those.
5 building blocks?
I just mentioned these are essentially the transistor, the light emitter and detector, which is basis of optoelectronics. So transistor basis of electronics, optoelectronics based on light emission detection, touch screen technology, and liquid crystal display technology. So those are essentially the building blocks. Of course, they are used in many ways, and of course, a lot of software goes in to use them, but that's about it. If you look at our courses, what we cover in our electrical engineering courses, we basically cover these devices. Then, of course, we apply them in circuits, and we apply them and we learn all kinds of things. But the basic building blocks are very few. And there's a need to expand this building block. And that's one of the things I'm going to talk about, because these devices have their limitations. And especially from the point of view of wellness, they have very strong limitations. So, of course, one then involves mathematics, software, and so on to make these devices come alive. Now, technologies can instantly change lifestyles. So, a technology like a cell phone technology going into a village in Africa or India instantly changes the quality of life of that place. And they leapfrog, and it's interesting to see. When I was growing up, I grew up in Delhi. Until I was about 15 years old, we didn't have a phone. And it took a 5-year waiting time to get a phone. And this was not ancient, I'm not that old. But it was a 5-year waiting period, then you got a phone. And of course, it was unthinkable for somebody in a village to have a phone. But now you go to villages anywhere in India, anywhere. And you go to villages in other parts of the world, and people have cell phones, and the entire network that was needed to sustain phone lines and all is basically totally irrelevant. So technologies can do miraculous things. They can create changes that people thought may take generations to create. So you can have cell phones anywhere. You can have access to internet in places that were almost hard to imagine how possibly you could have things like internet there. And with profound effect on people's lifestyles. Now, new materials are coming in with semiconductors, and for example, carbon nanotubes, which are very exciting, graphene, which was the basis of a Nobel Prize, I think 2 years ago. Now, beyond, so still semiconductor devices respond to essentially electric field, electromagnetic field, force, pressure, temperature, light. They have very poor response to magnetic fields. So if you have semiconductors, they have very poor response to magnetic fields. Now, magnetic field response is very important for a lot of applications. But semiconductors themselves, so technology itself does not have a very good response to magnetic field. They have very poor response to individual molecules. So if I have a computer or chip from any semiconductor and I want to know what is this particular chemical molecule that is in the air, semiconductor technology is not very useful there. Very poor response to pathogens that may make me ill. And so for these kind of things, these individual molecules, chemicals, pathogens, and so on, currently they're detected by chemistry. Right? So if you have, if your child or has a strep throat, and you want to know what is strep throat, you have to bring them to a physician. The physician has to do a test, and there's a long test and a short test, and the long test is a reliable test. So they send it, a culture is developed, some kind of growth is done, and then you know, okay, this is the illness. Even though all you're detecting is a particular molecule. Right? But because semiconductors can't do that, you have to go through this chemistry or biology or growth and cultures and so on. And it would be great for semiconductors to enter that arena. Right? It would be great for semiconductors because semiconductors can do miraculous things. If so, semiconductors can detect, I can receive a signal on my phone from anywhere in the world, and I can browse and look at Wikipedia anywhere in the world. So semiconductors have miraculous properties, but they don't yet have the property that here's a pathogen, and I want semiconductor to tell me what is it. Right? So that still has to be done by chemistry or through mass spectroscopy, which is basically figuring out the mass of that molecule through passing it through an electric field, magnetic field, and mass spectroscopy. And that's the basis of chemical detection even now. That's slow, it's costly, it's cumbersome, and semiconductors should enter this arena. And people, of course, recognize it should, because that will have a profound impact on our wellness.
But they do mass chromatography on the chip now.
Yeah, the chip is there to analyze the signal. But what I would want is the chip to send a signal in and detect it just through spectroscopy. Just like we detect from a radar, we send a microwave signal and we find the signature. So that's the ideal model. So of course you can do mass spectroscopy. And if you go to the airport, they do that. They take a swab, put it in, and it takes 2-3 seconds, and they tell you. But what I'm suggesting, semiconductors to enter the arena where they do it just like they detect a microwave signal. And what is needed for that is not present in semiconductor technology right now. So I look at these 4 areas, some of them very simple. One, so coming to where technology needs to go, should go, it's already there sometimes. Physical safety, which means safety from injuries, accidents. If you know why an accident is caused, it should not happen. Right? If you don't know, then of course, that's a different story. But if you know this is the reason for an accident, then technology can ensure that it should not happen. Right? That is the power of technology. Secondly, mindfulness, trying to remove the gap between knowledge and action. That is, of course, difficult, but technology can play a big role because a lot of our lack of wellness is because of this gap. We know something, but we do something else. And it seems like a very difficult gap to overcome, and technology can provide some of the resources for that. So this is A, this is B. I'll talk about 4 of these. Then new devices, which would be sensors for new chemicals. right? And those have to be based on terahertz devices. And currently, technology has a big gap in that arena. And there are reasons for that, reasons why semiconductors have such a hard time detecting terahertz radiation. But of course, that's where the excitement is, to overcome that gap. And if terahertz devices become as common as gigahertz devices, which are totally common, right? So in every device there are gigahertz devices, but we don't have terahertz devices at the same level. We also have devices that are optical. Right? So there is a gap here, and that fulfilling that gap has a profound implication for our wellness. And self-awareness, and this is a little more, I would say, esoteric, knowing myself, awareness of the culture around me, and learning and knowing techniques and implementing techniques for stress release. Right? Because that's one of the sources of poor health, especially in developed countries. So stress and stress relief is one of the most important challenges in modern society, because stress is so pervasive, and it's the kind of stress that our brain doesn't know how to handle. Right? So our brain knows how to handle certain kind of stresses, but the stresses that are coming in modern life, our brain has no idea how to handle them. Right? And what can technology do to enhance that ability to handle that stress? So A and B, this first part, actually the technology is already there. And it's more a matter of engineers and people of concern to force such technologies to come in, because they're already there. And they are very cost effective. If one looks at a holistic picture, so they're very cost effective. The last ones are challenges, right? Because technologies don't exist. And so new kind of technologies have to be developed. So I'm going to focus on the first one, preventable causes of death. So it's a macabre kind of cartoon, but just to kind of give you an idea, here are motor vehicle accidents, collisions, firearm death. So typically in car crashes, about 35,000 people lose their lives, just in the US. Right? Worldwide, it's more than 1 million people just dying in car crashes, which is an incredible number, right? Especially in this country, where we value life so much, right? Where we are willing to spend millions and millions of dollars for certain kind of preventing certain kind of tragedies. But this is a routine tragedy. It's a routine tragedy where 35,000 people die just year after year after year. Right? So purely from a physical safety point of view, the cost of car crashes, and of course, it's very difficult to evaluate a human life. What's the cost of human life? But the raw cost, dollar cost of car crashes is $200 billion, right? Which is roughly half of the revenue from car sales. Right? So if you look at the number of cars that are sold, about 12 million cars are sold every year in this country. And you can calculate what's the revenue, what's the total. And this 200 billion is a big fraction, right? 50-60% of the car sales. And that's just a loss every year. Accepted, and culturally it's accepted. And at the same time, of course, we know our response to a terrorist act, right? Where a few lives may be lost, and very rightfully, very correctly, a lot of resources are put in. Right? But this is an area where it's surprising why culture is accepted. So cultural, it's important to understand why the culture accepts. And I, of course, myself don't understand. I'm not a cultural anthropologist, but it's always a dilemma to me. How is this accepted? And especially because semiconductor technologies make this preventable and not at a huge cost. So car accidents, or of course any kind of accident, really brings in this picture of asymmetry in the arrow of time. Before the car accident, you're fine. After the car accident, you're really not fine. So this huge asymmetry. And right at that point, you're totally fine till you are in the crash. Right? And often, people can see their lives passing in front of their eyes. That asymmetry in time, that a fraction of a second before, you're totally healthy. Fraction of a second after, you're devastated. And so it should not happen. So if one looks at, and you can go to the AAA website or you can go to some of the other sites, and they list why cars crash. And 99% of the cars crash because of human error. So they're completely, and of course human error, one can say, well, humans make errors, but the technology is there to prevent those errors. Now the challenge is, of course, in this technology, it's not a sexy technology in the sense that it's not a technology which requires incredibly complex systems, because the technology is always, it's essentially there. Right? It's the implementation of the technology. And it's more a cultural issue where one accepts that this is how it is. Right? So when our kids turn 16 or 18, we give them a key and we just hope they're all okay. Right? So it's accepted. Well, teenagers will crash. Why should they crash? Why should they suffer? Right? Because the technology is already there. And interestingly, semiconductor manufacturing ensures that the cost of most technologies is in the range of $100. Right? You look at an iPhone or a smartphone, what an incredibly complex technology. If you think about what that complexity of that technology is, in the range of $100. Right? You look at a camera in the range of $5, $2. It's incredible what semiconductors do. So it's not an issue of, well, it's so expensive. That may have been an issue 10, 15 years ago, but now it's not an issue. So cars can essentially be immune to accidents. Right? And the technology exists. Power tools, which are, interestingly, I was looking the other day in preparation for this talk, the power saw causes about 600,000 fingers cut off every year in this country. So 600,000 people lose their digits in power saw accidents. Right? And it's a completely preventable accident because you can completely make the power saw safe. And I'll show you the technology which is actually existing for a number of years, but it's not implemented. Again, because it's just a culture that says, well, that's fine. Right? Of course, for the person for whom it happens, it's not fine, but the culture says it's fine. Right? And it costs only, this is a good range, good number of what a particular technology will cost, given the way semiconductor technologies are manufactured. Firearms can be immune to accidents. Right? So I'll show you a picture of a German pistol, which has that technology. So these are existing technologies. They don't require, they just require a change of culture, but they'll have a profound effect if they are implemented. This is, just reiterating what I mentioned, the leading cause of accidental deaths in, so of course the motor car, the automobile is the dominant, so it's a huge, but also interestingly, the big tragedy is the age at which people die or suffer injuries. And the peak occurs just at that very young age. And it's accepted that, well, 10, 12,000 young people will just die from car accidents. So it's accepted. And it's unfortunate. Right? So as I was mentioning, the cost of car accidents is $200 billion. That's about half of the revenue from car sales. Right? So a big fraction is, and that's not counting the tragedy of the, of course, the death. Then there are other technologies. I was looking at, looking at a website, Alibaba. This is an anti-sleep device, nap alarm, ear alarm, preventing drivers from sleeping. Its cost is only, so you can see, read over here, US dollar 70 cents to $1. Right? So this entire device just for less than $1. Right? This is the German firearms producer. They produce this gun, which will not fire. It's completely off unless you have this wristwatch which sends a wireless signal to enable it. Now this is a very trivial technology. For the kind of technologies we deal in state-of-the-art technology, this is a very trivial technology that just disables something unless a wireless signal comes. And of course, hundreds and hundreds of small children die because they accidentally pick up their parents' guns and shoot themselves. So some of this is inexpensive. It's not an expensive technology because wireless signals are widely available, and these technologies are widely available. This is the power saw I was mentioning. This power saw, and if you get a chance, you can go to, I think it's called Saw Stop. It's a fantastic website where they have a lot of information on this technology, which costs about $100. It adds a cost of $100 to a commercial saw. And they have, of course, some interesting stories, and also a demonstration of this saw, which has a digital signal processor out here, which measures the impedance of the saw touching the object it's cutting. And it knows if the object that is coming is something like human flesh, it instantly stops the saw. It instantly stops. And the demonstration is incredible to see. And it's a very simple technology, but it's not accepted, again, because of cultural reasons. So as far as safety is concerned, this is not that but this is very important from a wellness point of view, to change the culture where people say, well, we should have this technology which would have this profound effect. Now, in terms of cars, of course, pretty much, Google is coming up with this driverless car, which interestingly, it was only in one accident, and that was the accident when the person was driving the car, right? So otherwise, it drove all over the world and didn't have a single accident. So the technologies are there which will eliminate essentially every source of accident in a car, right? Whether it's distracted driving, or a lot of accidents occur when people are backing up, right? This is a trivial technology. This only costs about $50, and this technology was up for review by the automakers, US automakers, I think 2 weeks ago, and they decided not to implement it, and it was postponed to 2014. Now, this is a very simple technology, and it's implemented in almost all Asian countries and many European countries. That every car has to have this backup camera. And it makes so much sense because in this country, there are about 4 children who die from their parents or neighbor backing up the car into them. Right? Like you can see this child behind. And that's a huge number, 4 per week. Right? And such a trivial technology. And of course, 1/3 of the car accidents are caused by alcohol, and this technology exists. Only a judge can enforce somebody to put this technology, but this should just be part of automobile technology. And of course, radar systems are there, which can completely guide you near a collision. So in terms of this first part, so I'm going to talk about 4 parts. The first part, the human response system is very slow. Right? So we are moving in fast vehicles. The car is moving very fast. Power tools are moving very fast. And our response is so slow, 20 to 100 milliseconds, and a car moves several feet during that time. So there's no way we can control the car, while the technology response time is microseconds to nanoseconds. Right? Having radar systems, so this is Volvo's low-speed accident prevention system. And if the will and the culture is there, all these technologies can be implemented. So that's the first part, where it's not that new technology has to be developed, it's technology can have a huge impact, and understanding that and developing systems from that point of view. The second part that I was going to talk about is wellness as a technology driver and the concept of mindfulness, and closing this knowledge action gap. Right? Of course, technology has been doing this forever. We all use our alarm. Very few people, I think, in the modern world who have to be in the morning at work, don't use an alarm clock. Right? Alarm clock is almost universal. Right? And if we didn't have an alarm clock and we just let ourselves wake up, a few of us would make it, but most of us would be late. Right? Very few people would have the natural alarm clock to, maybe farmers do it, and if the farmer is late for 10, 15, 20 minutes, it's not that big a deal. But in modern life, we can't be late. Right? So an alarm clock already closes that gap between knowledge and action. Right? We know, okay, we have to be at work at 8 or 9 or whatever, and this simple technology of alarm clock makes it happen. Right? And without that technology, most of us will be late. We also, of course, use our phones, our smartphones, our tablets, and whatever, to constantly tell us about the day, timetable, appointments, and so on. But it can be much advanced, much more. So simple technology, the compass. Now, mindful technologies are present, and these are also technologies that are available in the ICUs, the intensive care units. There are so many technologies which could be called mindful technologies. Keep the staff aware of what's going on. Right? The staff is not capable of actually keeping track of all the patients. They are not that. It's impossible to be that mindful, but technology helps them. Then, of course, there are technologies all over in the road, signs and so on, informing us. Yesterday, we heard the siren, tornado warning siren. It reminded us, don't go out, take cover, those kind of things. But well beyond that, what can technology do? And so what can technology do to change behavior in a positive way? Right? Because behavior change has become the biggest obstacle to wellness. Right? Especially in developed countries, behavior change is the dominant source, not being able to implement what you know. Right? So almost everybody knows the kind of food we should eat to stay healthy. Everybody knows the kind of exercise to do, relationships to have, but yet we can't do it. And that's where technology can play a very important role if it's designed from that point of view. Of course, right now it's not designed. Often technology becomes itself a problem. So often technology itself causes further, so we get addicted to our Game Boys. Well, not me, but children get addicted to their Game Boys, don't play outside, those kind of things. So the fact that information has now come into the individual's hand is a big resource if it is used properly. So wellness right now, so 30 years ago, the information was in the hands of big entities, insurance companies, big corporations. Now information is in the hand of individuals. We can ourselves manipulate and contribute information. Wellness now is in the hands of the medical business. Right? But it can also come partly to the hand of individual. So when we think of wellness, we think, okay, I'm sick, I have to go to a doctor. Right? And a different mindset would be, I am my own healer. Which requires a little bit of a little different way of thinking, and also then closing this gap between action and knowledge. So can technology control individual behavior? Can we use technology to change our behavior? Now this is the hardest thing to do, and study after study has shown that changing behavior, something as simple as how you eat, is such a difficult thing. It's an extremely difficult thing. But what can technology do? Now we know that technology does change behavior. We know from our own experience, we can see other people, technology is a very powerful behavior changer. It's just that it's not been used as much in implementing and specifically designed to change behavior. This is a very important example of technology helping change behavior. It's a flight simulator. And the response of a pilot to emergencies, turbulence, the plane dropping 50, 100 feet is very different from an average person's. Right? And it's not like the pilot was born that way. Right? So the pilot's behavior to stress can be completely changed through a flight simulator. Right? And flight simulator kind of technology is coming into everyday life. So I want to change my behavior. Can I get a technology that is equivalent of a flight simulator? And that's an opportunity for technologists to contribute, to develop. This is one of the only places where behavior change is induced through direct technology. Right? How a pilot reacts under highly stressful environment. Not only learning how to drive or how to fly a plane, but what to do and how to stay totally calm under extreme emergencies. But we need that. I need something like this. Right? So when I go through stress, this is what I need. Right? Except my stress is not flying a plane. It may be something different. Right? And having technologies. Now, this is implemented basically on microelectronics and optoelectronics. And so there's an opportunity here to bring technologies that allow us to change behavior, because that is the hardest thing to do, and that's the biggest cause of illnesses. So technology, of course, we know it creates products that change people's behavior. So whether it's surfing or smartphones or games or social networks, technology changes our behavior. Right? And so there is an interest now, growing interest now in engineering departments to develop technologies from this point of view. Right? Because so far, changing behavior, it's always kind of thought of, well, that's an arena of psychology and therapy. Okay? But it's an opportunity for technologists to think, what kind of technology can I develop that will actually change somebody's behavior? So, for example, to make you eat slower. Something as simple as that. That's very difficult to change. Right? So if you see somebody eating and they eat very fast, to make them change their habit to eat very slow is extremely difficult. Okay? But can't technology contribute in that arena? Why does that have to be only the arena of therapy and psychology? Right? Because we know technology changes behavior. So there's an opportunity for technology. Of course, technology also changes the brain patterns, and sometimes in a bad way. This is the brain patterns emerging after playing violent games, video games, and kids' brain patterns are changed. Okay? This is not a good way of applying technology, but there could be counter ways which can actually take you in a different direction, right? Of course, depending on what you want. So preparing a brain through technology for workplace posture, simply sitting properly. Right? Apparently, most of the back pain, which is a huge issue, is simply from not sitting properly. Right? And that's simply a reminder technology. It's a very simple technology, just reminding people to sit properly, and just kind of aligning. Maybe a chair giving you a little nudge while sit properly. Right? Then workplace demands, other kind of stresses that occur, developing technologies from that point of view, that recognizing that just looking at back pain, this is one of the most important problems in developed societies. Almost everybody, they say almost 70% of the people will have serious back pain issues at some point in their lives. And it's primarily related to how you sit. Now, there are some degenerative diseases which are different, but most of the issues are related to how you sit during the day. It's very simple. And that's, so there's opportunity there. So I'll continue a little faster. Where can technology impact? So this is the third part where I was mentioning about this gap. So if you look at the electromagnetic spectrum, we have electronic devices that go up to 100 gigahertz or 200 gigahertz. We have optoelectronic devices that start at 10 to the 13 hertz or 14 hertz and then continue on after that. In the terahertz regime, there is a gap. Right? So neither transistors respond at that frequency, or if they respond, their response is so insensitive or so poor that the noise overwhelms the response, nor do lasers or other optical sources respond there. Right? So there is this gap. And this is a very important gap because it all happens also, and in fact, that's part of the reason why there is a gap, because most molecules have signature frequencies in that region. Right? So if you look at almost any molecule, whether it's carbon monoxide or a pathogen or a more complex molecule, a protein, they all vibrate in that region. And that's part of the reason that's a challenging space, because the semiconductors also have their lattice vibrations in that region, right? Which interferes with producing the device. But that's a huge opportunity, and there are a number of groups working to fill this terahertz gap. And this gap essentially would mean that you can have spectroscopy just like a microwave tuner can pick up any frequency. It can tune to any frequency. You may be able to tune, and of course that's a big drive for this technology. Now this technology does not exist. Right? Of course it's a research technology, but this would have profound implications for having things we need to go to physicians to test. Right? So if I have a sore throat and I want to know, should I be on some medication, I go to a physician. Right? And half the time, it's just a sore throat. They just say, go home and rest, eat, drink some soup, have some soup. There's nothing to do. Right? Why should I have to do that? Right? So if I have these technologies, I should be able to just, point something at my throat and know what it is. Right? But that requires this terahertz kind of regime, because then the technology is in my hand. It becomes very, very simple. So most of the detection, of course, semiconductors are used in analyzing the analysis, but they're not used for directly getting the signature of these molecules. And of course, the TSA has been, running around trying to develop these technologies. And often, you may have, about a couple of years ago, I think there was this puffer that came out where you would go through this machine and they would blow puffs of air. Now that technology turned out didn't work, and millions of dollars were abandoned. So a lot of the technologies that are currently being used, and every time you go through an airport, you encounter these technologies, they are very challenging technologies. Yet, if we have terahertz devices, it would become trivial technologies. It would become like pennies for that. So right now, something like this, of course, this has been abandoned after spending close to $100 million, because these machines were like $100 million. Semiconductor devices are a few dollars, right, or even less. But we don't have a terahertz system. Again, this whole thing. Now, detecting pathogens, molecules, semiconductors are not good at that. We don't have technologies where you can say, here is a pathogen, can I detect it? So developing sensors, this is a cartoon of a transistor. Right? Normally, transistors detect voltage or electromagnetic signal or photonic signals, but developing new classes of devices which are not there yet. Right? So, but they'll have a profound effect on our wellness. Right? Being able to detect pathogens just like we can detect electromagnetic signals, sort of health sensors based on semiconductor and other material technologies. Finally, I'll take a few minutes and talk about this idea of self-awareness. What can technology do in self-awareness? And the last talk that I'm going to give in this series focuses almost entirely on this area. So I'm just going to introduce this. Human wellness is profoundly connected to knowing yourself, understanding yourself. Unfortunately, this is an arena which technology, of course, has no input in yet. So when we look at this group meditating, meditation is a very important part, and it will become more and more important part of human wellness, because the cost of getting sick, getting depressed, getting mental illness, not being able to release stress is so huge. And the cost will only escalate. So understanding how can I release stress? Because as I was mentioning, even at University of Michigan, which has very intelligent people, very educated people, more than 50% of our healthcare budget goes towards illnesses that are originating from mental stress. So releasing mental stress is a profoundly challenging thing for the human brain, because the human brain has evolved under conditions which were so different from our conditions we are living in. And of course, technology contributes to those conditions. So the kind of stresses we deal with are so different from what our brain knows what to do about. Right? Simple things trigger the stress, and the stress just doesn't leave. And it results in outcomes that are profoundly bad for us. Right? So meditation techniques address that issue. How do you release stress? And there's a lot of established techniques. And now the good thing about technology is that they can verify the benefits of such techniques. Right? Because you can directly put somebody in a chamber and you can observe the impact of their brain wellness through meditation techniques. And there are other such things that are known in cultures but not known in technology. So self-awareness, which basically part of the outcome of self-awareness is how to release stress. Not only self-awareness, which is a whole field, but how to release stress and how to let go and relax after a stressful event. So the human mind remains primitive, which basically means stress lingers long after its positive benefit. So stress has a positive benefit. Right? There is a purpose to getting angry, upset, and so on, but the purpose is only for a short time. Right? But we can't let go of that stress. And that's the challenge. And that's where these mindfulness techniques, meditation, help. Right? That's what the purpose is. Because it's not like a person who knows meditative techniques doesn't get stressed. It's just that that person knows how to release it very quickly. Right? And that's where technology can have a profound effect, because more and more as technology develops, and especially if one sees where technology is going, this will be the dominant challenge to our wellness. Right? Not being able to let go of stress, and then the stress lingering, and then gradually pulling you down, like draining you away. Right? Not being able to turn your brain off from a state which is in a ruminating state. Your mind wanders naturally into this dark state, and then it stays there. And one needs to know what are the tools that pull it back out of that state. And these tools are provided by meditation techniques, but the technology is not yet there to actually provide us guidance in that area. So technology periodically interrupting us to take us through from our dark state to a brighter state. Of course, without chemistry, without chemicals. Of course, right now the main way to deal with this is antidepressants or other kind of chemicals, right? Which have a great value because if that's what you need, you have to take it, right? But there are other techniques, because chemicals have other implications. They have other implications. In addition to not just costly, but also they may take you into a different direction, may become addictive, and so on. So meditation tools implemented with the help of technology. Now what that requires is technology that is able to sense the brain. So you don't have to actually go to a MRI chamber and say, okay, what's the status of my brain? Technology that is coming to the point, and I mentioned that one of the arena where semiconductor technology is very weak is detection of very low magnetic fields, right? Which means it's very difficult for semiconductor technology to actually detect very small brain signals. That technology is more expensive. It's difficult, it's cumbersome, more expensive. But considering what semiconductors can do in other arenas, as well as other material systems, so very high sensitivity, which not only detects the brain state, but also the breathing pattern which nudges us with suggestions and takes us into a less dark state. So with that, I'm going to end, and I'm going to actually do this for you. Right? So I'm going to make you laugh by doing this last thing. So I'm going to provide you that technology now. So we're going to stand up and laugh. So let's do a 1 minute yoga session. So 1 minute yoga session where first I'm just going to help breathe with you together, and then we'll use laughter to change our mind state. So let's just stand with our heels touching if you're comfortable. So you're grounded into the earth, and pulling your shoulders back, open your heart. So feel like your heart is opening. And release your arms like you're releasing all your burdens. And open your throat like you're fearless. And then bring your hands forward and gently touch your fingers. And on the inhale, we'll bring our arms up, reaching up to the sky, like we are from the earth to the sky, that big. And on the exhale, we'll slowly come back. So it takes a slow breath, so pressing your diaphragm out. So let's inhale up. Exhale back. Let's do one more. next 3 breaths. When we exhale, we'll just laugh out as hard as you can, and you see how your brain changes. Right? So let's inhale. And let's do 2 more. And 1 more. And you see how your brain changes. So that's what the technology should do. It should take you out of your chair every 1 hour and make you laugh. So thanks for coming.